Okay, today we are going to be continuing our discussion on circles and different types of things going on in circles. A couple of days ago, we introduced the concept of a tangent. Today, we are going to look at what math can be found about what's going on inside of the circles with tangents. Ah, hit the wrong button. Here we go. Oh, I actually didn't want one on that page. Never mind. Anyway, this first page is kind of review. So for those of you that have been paying attention, okay, this should be nothing new. As we said before, what did I just do there? Okay, as we said before, lines that are tangent to a circle. Okay, you've already got the definition for a tangent. They're tangent to the circle, and the one property that we've discussed so far is when a tangent intersects a circle, it's going to intersect it in such a way that the tangent is going to be perpendicular to a radius that connects at the point of tangency. Okay, we looked at that last Thursday. Okay, so this diagram right here in the middle of the screen, that one you pretty much already have. Okay, now we also kind of hinted at, of course, the same thing you've heard me say a dozen times already this year. Wherever you have right angles, you're most likely going to end up with right triangles. And then when you have right triangles, you get all kinds of math starts popping up, like Pythagorean theorem, SOHCAHTOA, stuff like that. Okay. Okay. Now, here is a sample of the kind of math that you're going to see, or that you might possibly see, when you get a tangent of a circle. Obviously, line segment XY is a tangent. Okay, it passes by our circle. It makes contact with the circle once and only once, and that would be point Y. What do we call point Y? That place where the tangent hits the circle? It's got a name. Uh-oh, that may explain why half of everybody didn't know it on the quiz Friday. Point of tangency, where the tangent makes contact with the circle, that's called a point of tangency. Y is a point of tangency in this diagram. Okay, so if you connect a radius in circle Z to the point of tangency, okay, it forms a right angle with the tangent. That's why you got the little right angle marker inside of there. Now, if you leave from the center of the circle, okay, head off out to point X, it completes a right triangle. So everybody can see the right triangle that's in there. Okay, so if you wanted to solve for little a that's in the picture, how would you do it? Yeah, Pythagorean theorem, right? If you know two sides of a right triangle, we can very easily figure out the third side of the right triangle using Pythagorean theorem. We have 2, which is a leg of the triangle. We have 10, which is another leg of the triangle. And the hypotenuse, a, is unknown. Okay, so just plugging into Pythagorean theorem. What's 2 squared? 4. And 10 squared? 100. Okay, so we've got 4 and we've got 100. What's 100 plus 4? 104, not exactly calculator math there. Okay, now we need to isolate y. Right now we have a square, or I'm sorry, need to isolate a. We have a squared. We don't want a squared, we just want a to the first. Okay, so how do you get the square off of the a? Take the square root. Doing the opposite, take the square root of both sides. Okay, now taking the square root of the right, obviously the square root of a squared is a. Now how do we figure this mess out on the left? Square root of 104, how does that work? What? I didn't hear. Calculator? No, probably not. Okay, I don't want that decimal point. What do you do with 104? You factor it, break it down, right? Figure out 104 is something times something. What are those somethings? Okay, so when you factor it all the way down, okay, what you'll end up with is you'll end up with 3 2s and a 13. What are we hoping to find underneath the radical? Pairs of stuff, exactly. Okay, so are we going to have any pairs of anything in there? Yeah, get a pair of 2s. Okay, takes two 2's underneath the radical to make 1 2 outside of the radical. So we're going to get a 2 outside of the radical. That'll take care of 2 of these 2's. What about this third 2? Is it going to have anybody to pair with? No. What about this 13? No. So they're going to be stuck. There's going to be a 2 and a 13 stuck underneath the radical. Anything that's stuck, you just recombine it. What's 2 times 13? It's 26. Okay, so there is your answer, 2 square root of 26. Now, if a question like this showed up on an end of year test, it would be a decimal point. Okay, so like somebody said, we would be able to go to our calculator at square root of 104, find out what the decimal point is, and I think it's something like 2.1, or 10.1, 10.2, somewhere in there. But keep in mind, on a PSAT or an ACT test, not only are you not going to have a calculator, the answers are not going to be in decimal points. They're going to be in terms of the radicals, which is why I want us to get used to simplifying them manually. Okay, but it's nothing more than a right triangle inside of a circle. It's not a big deal. Does anybody have any questions on that problem? Okay, let's look again. This is where the problems start to concern me right here. If they gave us that last problem, I wouldn't have any concerns about that. I would say that anybody that has any idea of what they're doing would be able to work that problem. What concerns me would be something like this. Okay, you're standing 8 feet from a cylindrical tank. It is 20 feet to a point of tangency. What is the radius of the tank? Well, for 5 months now, I've been fielding various questions from various people. When am I ever going to have to use this? What purpose does geometry have? What does it apply to? Okay, it's got lots of applications. The problem is we had to get a little smarter before we could start to see how some of these things are going to apply. Okay. So you're standing 8 feet from a cylindrical tank. It is 20 feet to a point of tangency. What is the radius of the tank? Okay. You ever think it's been a situation where somebody's bought a piece of property and there's a tank of some kind sitting on the property and they've wondered how big or how many gallons the thing may be? Absolutely. Okay, what do you think they do? Pull out a water hose and start dumping water into it and then measure out the number of gallons? Absolutely not. Okay, there is geometry at work here. This picture, or this problem, is described by something that basically could be this. Okay, you got a person standing there 8 feet away from a tank. Okay, it said you're 8 feet directly away from it. Okay, so it's also 20 feet to the point of tangency. Are these measurements that can be found by Joe Blow standing on the ground in front of a big metal container? Could he measure 8 feet away from it and put himself there? Could he say, okay, there's the point of tangency, the very edge of the tank where I can no longer see it anymore, and measure to that point, position himself in space 8 feet away from the tank, 20 feet to the point of tangency? Yeah, okay. With the math that we've got going on right now, we can figure out what the radius of the tank is. Okay, and if we have the radius, we can figure out things like surface area and volume and stuff like that. Okay, so there he is. Now, what's different about this problem compared to the last problem? Yeah, it's outside the circle, but on the last problem, wasn't part of our triangle outside the circle also? So what are we missing on this problem that the last problem had? Yeah, it had the rest of the triangle that was inside the circle, right? Well, does it still exist? Is that triangle still inside the tank even though we don't have it yet? Yeah, we could finish that off. All that's missing is, I mean, the 8 feet to the tank, but then the radius on the other side of the tank wall going to the center of the tank. And also the radius from the center of the tank reaching out to the point of tangency. Okay. Well, it's still a right triangle, right? How did we solve the last right triangle? Pythagorean theorem, right? A squared plus b squared equals c squared. So let's have a look. There's that triangle. I just took it out of the cylinder so we could still see it. What are the legs of this triangle? (20 and r). Okay, not a trick question. 20 and r are the legs of the triangle. How would we express the hypotenuse? Is it 8? Is it r? Is it a combination of 8 and r? Yeah, okay, so what kind of a combination? Should we add up 8 and r? Should we multiply them? What do you think? Multiply them? Okay, so if I said that it is 6 feet from my desk to this spot in the room, and it's 10 feet from this spot in the room to the wall, I'd add them up, right, if I want to know how far it was. So we don't want to multiply 8 and r. We just want to combine them by addition. Okay, so 8 and r are going to want to add. So we're just plugging into Pythagorean theorem. This looks different than any plug-in we've ever done with Pythagorean theorem, but does it not still represent what the triangle's doing? One of the legs is r, one of the legs is 20, and the hypotenuse is whatever r plus 8 is. Okay, now this looks different for a couple reasons from any Pythagorean theorem we've ever seen before. We've never seen a binomial sitting right there, r plus 8. Okay, and we also haven't ever seen variables in more than one place in Pythagorean theorem. Okay, so the question becomes, are we going to be able to solve this because there's variables in two different places? And the answer is yes, you can solve it. Okay, and the reason you can solve it with two variables is it's the same variable. It just happens to be in two different places. So since I've got r in two different places, that's okay. But if it had been an r in one place and an s in a different place, well, r and s, those are two different variables. We wouldn't be able to work with two at the same time. But since it's just a single variable, we can work with it. Okay, let's see if we can't figure this out. What's r squared? It's r squared, right? We don't know this yet. Okay, what's 20 squared? No, 400. Okay, because when it's squared, you get the 0 twice. So you got 2 squared is 4, and then 0 squared, you get 0, 0. So 20 squared is 400. Okay, now what does this mean? R plus 8 in parentheses is being squared. What does that mean? Does it distribute? Does it just go get the r and square it? Does it go get the 8 and square it? Does it get both of them? Or does it do something completely different from even that? Okay, and here's one of the things where they're going to try to get us. Okay, the parentheses are being squared. What does it mean when you square something? Multiply it by itself. So the parentheses are being squared. So what's getting squared? The parentheses. So we need one set of parentheses times another set of parentheses. Okay, and that is something that they do catch us on fairly frequently. Okay, a lot of people want to try to distribute the square, just do r squared and 8 squared, and that's not how it works. Parentheses squared means the entire set of parentheses gets squared, and I'll show you how that changes the answer here in just a second. Okay, so let's have a look. How does this work? You have a set of parentheses times another set of parentheses. Okay, you probably had an Algebra 1 teacher at some point in time that told you to FOIL. Remember this? Told you to FOIL? I absolutely hate that term. I hate FOIL. Okay, FOIL works when you do a binomial times a binomial. Typically what I say is when you have a set of parentheses multiplied by a set of parentheses, you need to multiply everything on the left times everything on the right. Okay, FOIL works if it's just two terms and two terms. Okay, that works great. But what happens if you have three terms and two terms, or three terms and four terms, or 3 and 3, or whatever? If you just do FOIL, you're going to miss some things. Just remember, everything on the left times everything on the right. So here you go. This little r right here, right on there, it's going to multiply not just by the r, but also by the 8. What's r times r? R squared. And r times 8? 8r. Okay, good. Now, since this left-hand r has gotten multiplied by everything on the right, we're going to scooch over and we'll multiply this 8 by everything on the right. 8 times r, another 8r, and 8 times 8, 64. Now, if you distributed, look what would have happened to you. If you distributed this square to the r, you would have gotten your r squared. If you distributed the square to the 8, you would have gotten your 64. You would have missed those two guys. Okay, that's why you have to do the entire parentheses times the entire parentheses. Let's look and see what we have here. Are there any terms that can combine on that right side of the problem? Yeah, we've got 8 r's and then we've got 8 more r's. Is there any reason for them to be separated like that? There's not. How many r's are there? There are 16. Very good. Okay, now this is looking absolutely awful at this point. Okay, we've got r squareds all over the place. We've got r to the first. We've got constants. Let's start cleaning this mess up. First off, okay, you've got r squareds on the left. You've got r squareds on the right. Okay, they don't need to be on both sides of the equal sign. Let's just put them on one side of the equal sign. Okay, so which direction you want to send them? Doesn't matter, right? Just pick a direction, right? Just like any other time. So we want to bring them to the left. So we're going to take these r squareds right here, and what are we going to do with them? What's happening to the r squareds right now? They are being added. Remember, if it's a lead term, whatever its sign is, that's what it's doing. It's positive. That means it's being added. The opposite of addition would be subtraction. So we'll subtract r squared and we'll subtract r squared, because whatever we do to one side of the equal sign, we have to do to the other to keep the problem balanced. You can't add them because they're already being added. If you add r squared, you're going to end up with 2 r squareds rather than none. Okay, but look what just happened. R squared take away r squared. That's going to cancel. R squared take away r squared. Poof, gone. Okay, and that's the way when you end up with in Pythagorean theorem where you have a variable, the same variable on each side of the equal sign, this is always going to happen. You're going to end up with that variable squared temporarily, but then when you go to work it out, it's probably going to eliminate itself. Now we've got just a regular old equation. Can we solve this regular old equation from here? I sure hope so. Okay, if we can't, we're in big trouble. What's the next step we need to do here? Subtract 64, get those numbers away from our variable. So subtract 64, whatever we do to one side, we're going to do to the other. Okay, that'll take care of the 64s over there on the right-hand side. 400 take away 64, I'll just go ahead and tell you is 336. 336 equals 16 R's. We don't want 16 R's. We want 1 R. Divide by 16, absolutely. Okay, whatever we do to one side, we do to the other. And that's probably calculator math for just about everybody, but there you go. Okay, R is 21. Congratulations, you just figured out the radius of a cylindrical tank without getting inside of it or on top of it to measure it or anything. Standing outside of it, you can tell what your radius is. Okay, using 2 very simple measurements. A little bit of a complicated Pythagorean theorem, but you get the idea. Okay. Now, some confused looking faces out there. It's going to take a little practice before this feels any better. Okay, but there you go. Is there anything on the screen anybody doesn't understand? It is a lot of work, I'll give you that. Okay, one last thing for us to look at before we call it a day. And that is a rule for tangents coming from a common endpoint. Okay. If 2 lines are tangent to the same circle from a common endpoint, then the rule is going to state that the lines are going to be congruent. And this is really kind of a no-brainer rule. If you were to think about the tank question that we just answered with the guy standing 8 feet away from the tank and he says it's 20 feet to the point of tangency, did it say which direction it was 20 feet? I mean, could he stand there? Could he measure to the left side of the tank or to the right side of the tank? It didn't say one way or the other, did it? Okay. Why do you think that is? Same distance either direction. Okay. So that's what this rule is basically establishing. So if you need a diagram, there it is. Okay. If you're standing at a common endpoint, it does not matter which direction you go as far as a point of tangency. It's going to be the same distance either direction. Okay. So that is all that this rule states. And I'm not even going to waste your time with an example of that, because whatever one length is, the length from A to C is going to equal the length from A to B. No big deal. Okay. The assignment is a worksheet that goes along with these tangents, and that is all for today.